Hello and welcome back to another AstroCode tutorial on C programming. This time we're doing an episode that's not part of the main series I've been working on the channel, which is really trying to go into in-depth explanations. This is going to be more of a quick overview of how to do a really common task in C, which is reading from files and doing basic file operations. So right now I've just got a file open in VS Code. Of course, you can use whatever your preferred code editor is. And in this folder, I've just got two files. So I've got this file called sum.c, which is just basically like an empty C file template that we're going to build on. And then I've got another file which is called numbers, which just contains a bunch of numbers stored on new lines in a text file. It's important to note that these blue numbers here, those are actually the line count. That's not part of the text file. The text file is just these white numbers here. So we've just got 1, 2, 3, 4, 5, 6, 7, and they're all stored on separate lines, okay? And the challenge here is going to be sum the numbers from a file provided on the command line. So the idea is that we'll be able to run a program which will take in a file name, open up the file, read the values from it, and add them together. All right, so let's get started. Let's first work out how to actually read from a file. And to do that, we're going to need to also include a thing called standard lib. So just like we could include standard input and output, we should probably include standard lib because it provides a bunch of useful values and tools for reading from files. All right, perfect. Okay, the next thing we're going to want to do if we want to open a file is get access to a file. So how can we do this? Well, using these inbuilt library functions, we now have access to a thing called a file object. So we're going to create a pointer to a file object, and we're going to call this, say, text file. Okay, so this is just a variable which is of type file pointer called text file, okay? So we're basically creating a file object, or at least storing a reference to a file object, and then we need to actually set that equal to something. So we can use a provided function called fopen, as in file open, and then all we have to do is give it a file name to open. So in our case, the file name we want to open is numbers.txt. So let's do that, numbers.txt. And we also have to tell C what kind of read mode do we want. So do we intend to write information to this file? Do we intend to read information to this file? There's a whole bunch of different ones. If you're interested, you can just search for the documentation for fopen. For this episode though, we're just simply looking at reading information from the file. Okay, so to read from a file, we just provide the file mode R for read. Pretty simple, always end with a semicolon. Okay, so to review this really quickly, we've created a file object called text file, and we've set it equal to the file that is produced by opening numbers.txt. Now this is just an abstract object that C provides for us. All you need to know that it's basically just a reference to some file object, and this function here actually creates the file object by reading from the numbers.txt file. All right, perfect. The next thing we need to do is just check that we actually were able to open this text file. Sometimes we might provide a name here which doesn't actually exist on our computer. So what we have to do next is just quickly check to see if we've actually opened a file successfully. So to do that, we need an if statement. Always wrap your conditions in brackets here. And we're going to just simply say text file, which is the name of our file as we've opened it into a variable. And we're just going to check that it does not equal null, okay? Now, null is this thing that's defined in the standard library header. Don't worry about it too much. We're basically just saying, it basically just means nothing. So we're just checking that our text file is not equal to nothing, because if it was, that means that we've actually failed to open a file. Okay, so if this happens, all we're going to do is we're going to simply printf and say could not locate file. All right, so there we go, and that's our error message. And let's of course finish with a new line for neat formatting on the command prompt. And then we're going to call a function called exit, and we're going to give it to 0. Actually, let's exit with -1. Well, actually, here there's a bug here. This should be equals actually. Sorry. So what we're doing is we're opening our text file, and then we're checking that if it is equal to nothing, as in if it's equal to null, if it's got nothing in it, if it doesn't exist, right? If that is the case, then we need to print an error message, and then we just need to exit. And using a -1 just signifies that this process finished erroneously and not as intended. Remember, 0 is a positive exit status, so this is a bad thing. All right. Perfect. So now that we've checked that we've actually got a reference and it actually exists, the next thing to do is to try and read from a file. And how can we do this? Well, if you're familiar with C, you might have heard of a function called scanf, which you can use to scan a string for certain information. But there's also a function called fscanf, which stands for file scan formatted. And this is one of the easiest ways to scan for specific types of information stored in a text file. Okay. Now there's lots of different ways you can read from a file. So if you search cfile.io, as in like if you literally make a Google search for, let me leave it as a comment here, cfile.io, IO stands for input output, you'll probably get a bunch of different results showing you all the different functions you can use. But for us, we're only interested in scanning specific things from a file, so we'll use fscanf, or file scan formatted. Fscanf takes 3 arguments. The first thing is we need to tell it the file that we wish to scan. In this case, our file is called text file, as this is what we've called it in our code. Okay, so we need to pass it that. The next thing is the format that we're scanning from. In this case, because we want to read numbers from this file, we're going to just simply use a % and D format specifier. These are the same format specifiers you use when trying to print to the console using printf and things like this. Again, search for C format specifier if you want to know all the different data types you can try and read. Okay, so by doing this, we're saying we want to try and read an integer from this numbers.txt file. Perfect. The next thing we need to do is give it the location or the value. Oops, I accidentally messed that up. The next thing we need to do is tell it where we want to store the information if it's able to find a digit in the file. So we need to create a variable for that. So because we're trying to read an integer, remember %d stands for digit, which is actually an integer. We need to create an integer variable. Let's just call it number for now, and we don't have to set it equal to anything. Then we can simply tell fscanf that this is where we want to read some information to. We're using the and here because we're actually giving fscanf a pointer to the variable that we want to store our number in. Okay, so we have to just remember this little and if we want it to read into that number. All right, perfect. So now bringing up a terminal, you can use whatever one you want, and compiling this code. This is sum.c for me on disk. We should see it compile. And if we run this code, well, nothing happens. And that's what we expect. That means that it didn't encounter an error because it was able to find this file. It does exist, but we actually didn't do anything once we had scanned that number in. So what we should do now is add another printf statement to actually print out the number that we found. So to do this, we're going to try and print a integer. So remember, %d for integer. Okay, and let's just follow it with a new line for clarity and for nice formatting. And now that we've given it a format specifier, we have to also give it the thing that we want to print. So number is the variable we want. Yeah. So what we're doing now is we're attempting to read the text file for an integer and store it in number. And then what we're trying to do is print that number to the terminal. Okay, so saving this code and compiling it again and running the code this time, you see that we get 1. And this is actually what we'd expect to see because our first number in our text file is the digit 1. Perfect. So what if we want to get more information? Well, we could create another integer variable, say integer number 2, for example, and we could copy our fscanf line and then change this to reading into number 2 and saving this file, and we could compile it again and go through all that rigmarole and see what it prints out. And okay, so it didn't fail, but we've only got one print statement. So okay, now if we want to read 2 numbers and print both numbers, we have to copy the print statement, paste the print statement, make sure to change the variable. You can see that this gets very tedious, right? There's a lot of steps. And as you can imagine, we might not always know how many numbers we're trying to print. If it was this much work of duplicating and changing things just to add another number to the output, there's got to be a better way. Generally, if you're coming into an instance where you need to repeat a lot of very similar code, that is probably a good candidate for using a loop. In this case, what if we looped over the file and just read as many integers as we can? That's probably the best method here. So let's delete most of our code. I'm going to keep our original scanf and our original number variable. And let's talk a little bit about returns. So if you've used C before, you might know, or actually any programming language, you might know that functions can actually return a value. Okay, so not only can they manipulate variables that we pass to them and change the value of variables we pass to them, but they can also actually give us back a value out of the function itself. Okay, just like how, see here, we've got an int, we've got our main function, and our main function returns an integer. That's what this int means. And that's why down the bottom, we always have this return statement and returning 0 for success. Okay, so that means that once this function is finished being called by the operating system, we give the operating system the number 0 so it knows that the process went fine. Okay, and just like that, fscanf can also return us some useful information. Specifically, fscanf will return a range of different integers depending on what happens. If it cannot find a match, it may return if it cannot find a match, it may return 0, and if it can find some matches, it might return 1, and there's actually a lot of different values it can return. But the key thing for us to know is that if fscanf has an error, or reaches the end of file, or runs out of numbers to read, it will always return -1 for us. And we can use that as our condition for our loop. So if we say that all we want to do is to just keep reading numbers from the file until there is no more numbers to read, well, that sounds like a good candidate for a while loop. So using while, and we're just going to copy this line of code here. So we're actually going to cut it out, and we're going to put it inside our condition here. So while the result of this fscanf function call, right, does not equal, now does not equal in C is !equal. So whilst this function does not equal EOF. Now what's EOF? Well, EOF is just a hash define, so it's a number that's been defined in the standard input libraries, and it just expands to -1. But it's just a more readable way of just saying, hey, if the result of scanning this file is not end of file, as in we haven't run out of stuff to read, then we can keep going. So every single time that this condition holds true, as in every single time that the result of us scanning for a digit is not the end of the file, then we will run the code inside the loop here. So I'm just going to copy our number variable down to above the while declaration, not that it matters. And now what we're going to do is inside this loop, we're going to put another printf statement. Yeah, and again, we're trying to print digits, remember, because we're reading integers. So we're going to print each digit followed by a new line, and we're going to print specifically whatever value is stored in number. All right, so quick recap. What happens is when we try and run this program, first of all, we just check that we actually got a file open and there was no errors with opening it. Then we declare a variable called number to store our number in temporarily. And then we check that, and then we attempt to first scan the text file for a digit and store it into the variable called number. And if that scan completes successfully, as in if that scan does not equal end of file, that means we can then print that number to the command line. And then we will loop back to the start of our loop, and we will try and scan once again for another number. If we find another number, we'll store it in the number variable, which overwrites the previous value. And then in that case, we haven't yet reached the end of file, so we will print that number. And this loop will continue until eventually fscanf will tell us, hey, actually, we did hit the end of the file, in which case we will no longer run inside this loop and print no more numbers, and we'll know we have printed them all out. So if we compile this program, again, saving your changes, compiling on the command line, remember to do that every time, it's so easy to forget, and running our code, you can now see we read every single number from the file and print each one on a new line. And just to prove that this is not some weird trickery, we can just go in here, we can change this to 31, we can add 45, and we can add 16, and you could just add as many numbers as you wanted. And rerunning that same program without changing the code, mind you, will still open that file and read all the different numbers. So this is one of the ways we can make our program read from a file, even if we don't know how much information is actually stored in the file. We can just keep trying to read the information until we hit the end of file. It's a really useful pattern. Okay, so remember our main goal for this episode was not only just to read through a file and get all of the digits out of it, but also to sum all of the members of the file and also have the file be something that's specified on the command line. Okay, so we've got a few more steps to go and we're going really speedy here. So the next thing we need to do is, well, every time we read a number, let's just add that number to a running total. Okay, so we still need to have our temporary variable here where we store each number that we read, but we'll create a new variable called running total. Okay, and we're going to start that at 0. So our sum is going to be 0 by default. Then we're going to replace our print statement here with a statement where we simply increase running total by the number that we read. Okay, so what does this mean? Well, first, running total is 0. Then, if we manage to read a number, we will add that number to the running total. Then when we read it, then when we read another number, we will also add that number to the running total. So running total will keep increasing, and we'll keep adding each number as we read it to the running total. And by the end of it, we will just be left with a sum of all the numbers we found in the file. So coming down and adding a new printf statement here, again, we're trying to print running total, which is an integer. So we use our %d format specifier, followed by a new line for neatness. And we can simply say we can simply type running total here. So now we'll, instead of getting each individual number separately, we're going to get the total of all the numbers in that file added together. So saving your changes, compiling your changes, and running the code again, now we see that the total of all of these numbers added together, or rather all of these numbers added together, came out to be 117. And again, we can make changes to this file, and without changing our code, we rerun it, we see that the total updates according to what the numbers it finds in this file are. So this is a really useful concept. Now we can neaten up our print statement a little bit. So maybe we say that the sum is like this, so that now we get nice formatting when we compile and print it. So recompiling our code again and running it, now it just looks pretty. So it says, oh, the sum in this file is 154. Perfect. All right, so the last part of this puzzle is that we are supposed to sum the numbers from a file provided on the command line. Now that's a bit vague, but basically the intention is we're supposed to be able to say sum and then my text file .text, and what should happen is our program should then find my text file and instead use that as the file to read from. So it could sum all sorts of different files, and we've basically implemented a command line application. So how do we do this? Well, we need to change our main function a bit, because our arguments, or at least when we pass text to our program by running it on the command line, say here we've got an argument, that information gets passed into our program through this main function call. So we need to bring back a fairly common pattern, you'll see. So we need to have an integer called argc, or argument counter, and then we need to declare an array of strings. Remember that you can think of a character pointer as essentially as a string. Watch my video on arrays if you're more interested about why that works. Okay, and we'll call this argv, right? Argv, which is the standard name for that. I can't exactly remember why we use v there, but that's just what it's called. And this is an array, so we need open and close brackets. If you're not sure, look up main function, like C main function, and you should see some more documentation about what this means. But basically, when we do this, it means that we are also receiving a new variable. So we have access to something called argc, which is short for arg counter, or in other words, how many arguments were provided to my program. Now, arguments are just the things that we type after the name of the program. So we could keep adding random things to this, okay? And in this case here, we'd have 1, 2, 3, 4, 5 arguments provided to our program, okay? And note that the arguments are just text that's separated by spaces. So arg counter tells us how many arguments were provided to our program, and this is the actual array that those arguments are stored in. So first thing we need to do is we need to check that our program was actually provided the amount of information we want. Okay, so arg counter will always be at least 1, okay? Because when you run your program by itself without any arguments, okay, so here we just be running our program without any arguments, the program name itself is passed as an argument. So it's really confusing, okay? So the arg count is always 1. And if we just back off some of this here, what we'd actually find is instead of this being 1, 2 arguments, C will actually tell us that there's 3 arguments because we get given the program name back to ourselves, which is kind of silly. And then we also get given the following arguments. So here there is actually 1, 2, 3 arguments. So arguments being just the total number of text space, like separated by spaces. So 1, 2, 3 different text elements. Okay, so that means that if we want a text file to be provided as an argument, that's going to mean we're going to have 1, 2 arguments. So what we need to do is just add a little simple if statement to say, hey, if the arg counter is actually less than 2, then we should probably throw an error. So we'll basically just copy this error block here, okay? Like so. And again, this just exits with failure. And then instead we'll change this error message to say, no file name was provided. Okay. All right, perfect. So once we've checked successfully that a second argument was provided, the file name was given to us, how do we access it? Well, the second argument, as in the second piece of text passed on the command line, will be our file name. So it stands to reason that it'll be the second element of this argument array. Okay, how do we access the second element of an array in C? Well, we use the number 1. Remember, we count from zeros in programming, okay? So if we come down here and we delete this numbers.txt, like hard-coded name of a text file, we can instead replace this with argv and this index, okay? So what this is saying is, from our argument list, get me the second element. Remember, we count from 0, so the first element would be 0, all right? So we're saying, from our arg list, get me the second element. Now, it's important to note that if we didn't check to see if we didn't make the check to see if there was the correct amount of arguments first, and we tried to read from this second element, we could end up with a crash or an error because we're trying to read a value that doesn't exist yet. So that's why it's important to check that there is that many values in your array. Okay, so reading the second value from our array, that should be the text file, and we're going to attempt to open that, and then if we can't open it, we'll say that text file does not exist. All right, so coming down, we've made a few changes here, so make sure you've saved your changes, which we actually haven't. There we go. And then compile the program again. Now, if we run our program without any arguments, you'll see that we get an error. No file name was provided. Okay, so how do we fix that? Really simple stuff. To fix that, well, we just use our command like we intended to. For example, we're trying to read here from the file called numbers.txt, so we'll just tell it numbers.txt, okay? And now you'll see that it correctly opens this file and sums it together. But we can also create a copy of this number file, and we could change the name. Say we'll call this other nums.txt, and in here we'll also change the values. If we save this, without having to change anything about our program, we can rerun our command, but instead say other nums.txt, and it now reads the changed other file and tells us what the sum of that file is. So now you've essentially implemented your very own command for the command line that can be used to sum numbers in files. Granted, it's not very useful, but this is kind of the basis of how every single command on your command line works. It just takes arguments and does something with them. So cool, we can do it. Now, one last thing to quickly check. What happens if we give it the name of a file that does not exist? We get a could not locate error. That's perfect. Our program is working. I know it was fast. Hopefully you held on. This is a really common application to try and write and see, and there's some really useful tidbits in it. So I'm just going to give you a full look at the code now so that you can reference this if you're trying to implement a similar program yourself. All right, hopefully you understand, and yeah, thanks for watching.